Hello, class. I would like to, using this conference Zoom, to record section 5.4. In this section 5.4 of chapter 5, the purpose of this section is you need to understand how to find the probability of, we call the empirical probability. Okay, so I want to show you and give you examples that make things easy for you to understand and compute or to find this empirical rule, this empirical probability, not empirical rules, this empirical probability faster. So you just need to understand the concept and then you know how to do it. So in this chapter 5, section 5.4, even though the PowerPoint given us too many information, they just try to explain to you how to find empirical probabilities. Okay, so I might go a bit like straight to the point that to make you understand easier, and then you can yourself read through this. I might scan over this, but I would focus on how to find this. Okay, so the whole chapter 5, from section 1.1 through 1.3, you're learning about like how to find probability of that and using modeling variation, stuff like that. So only for this section, usually teacher using this section to personally is me. I'm using this section to make student do a project. Okay. However, for in this class, currently right now, I don't give you projects. Instead, I give you many homework and quizzes to do it. Okay, so now we can start 5.4, finding empirical probabilities. So first, I would like to give you a bit definition about this. Empirical probabilities is mean. So when we're talking about probabilities, we would like you to compute a percentage, right? A percentage can convert into decimal value or fraction form or percentage form. So it's either way. So in order to find this empiricals in this case, I'm not talking about empirical rules, okay? Empirical rules already mentioned in previous chapter, but for this chapter, for this section, empirical in this section meaning that you will looking for the number of the success. And to find the probability of the empirical, or another word, empirical probabilities, to find this, we have to record all your observations or the number of success from your observation divided by the total of the trials or the total of the outcomes. That's the purpose. So the example that I can give it to you is, for example, I want you to flip a coin like 10 times. Okay, so you have to flip it yourself. So you got the total outcome, you got a total, the number of your flips, and I want you to find the probability of finding the empirical probability of a number of the heads of the coins. Then what you need to do is you have to flip the coin by yourself and then record it. Okay, record it from what you observe. For example, the first time you flip the coin, you got a head. The second time, let me annotate this for you. I would like to annotate when I'm talking so that you can visualize easier. So draw. Okay, so for example, the first time you flip the coin, you got a head. Okay. What happened here? Who can see what you share here? Recording on. Yeah, one more time. I don't know why they don't let me write on it for now. Let me see. Recording is on so the account owner and everyone in the meeting can save the things you share here. Of course, yes, but why don't you let me draw? Okay, I click that. Let me see. Oh, how come? Okay. Yeah, maybe I'm running out of battery for my pen, so I'm going to use my finger. So again, for the first flip of the coin, I got a head. The second time, I got a tail, maybe, and then I got a tail again, and then I got a tail. I got a head, and the next flip, I got a head. And next I got tail, and then I got tail all the way, for example. So how many times? So I said 10 times, right? Flip the coin 10 times. So one time it has, the second time is tail. So got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, for example. So for this probability is kind of is very straightforward. So you just record what you done the experiment, and then you record it, and then you're gonna have all the values that I wrote up there. So the number of times I'm having is that, and I have the just random the number that I observe, I see it. So then I saw total is 10 times, right? 2, 4, 6, 8, 10. And then to find the probability of the head, for in this case, I got P of the head. And then you count how many of the head. So 1, 2, 3, 4, you got 4. So out of 10 times of the fifth. And you simplify, you got 2 out of 5. And in order to find the decimal value, you takes 2 divided by 5, you got a decimal value. Or you want to find the percentage, you got that multiplied by 100%, you got the percentage. But to me, fraction is fine. I don't mind. So just like that, and I will teach you how for in this section, they will show you like because we're doing by hand, so I give you just small number. But like for example, if you want the more accurate of the empirical probability, you have to do many times, like 100 times, 1,000 times, stuff like that. Then some people using technology to simulate and finding the probability of the empirical for the case. Okay, so let me move in details what's going on here, okay? I just give you like the overview, like kind of the general information, how to find the empirical probability. And some people might be curious more, and then you can read more from the PowerPoint like this. So like this, for example, based on the observations of the real life events, right? So that is how, they define empirical probabilities. So example they give this to us is baseball players batting average. Or another example is percentage of the time of the times a bus arrived late. So if you like thinking about these two examples, you can take, example of the bus. You compute by getting the number of the time that the bus arrive late, and then, like just estimating the total of the time that you observe, then you divide by that to get a percentage of the times that the bus arrived late. So arrive late in this case can be a number of the success as well, because they want to focus on the number of time, the percentage of the time a bus arrived late. So then you just focus on the time that the bus arrived late divided by the total of the time that the bus come. It's like that. So right here, we call it, the observation of real life events. That's how another way they compute the empirical probability. And another, let me say, when we can't find data, or when a situation is too complex for us. For example, like what do they mean? Like the situation is like too too vague or too many times you cannot like pay attention to each single event, then you cannot find that. So to find the empirical probability of the random events, we can sometimes simulate the situation to generate data needed to define the empirical probability. So sometimes many difficult for this empirical probability, to me is not really like because when you do this type of experiment, you need to be patient, you need to be carefully so that you don't miss out the data, because every single when you find probability of anything, any event, you need to get a big amount of the number of trials, so to get more like close to the actual value of that event. However, for this section, I usually we don't have like, I don't have a lot of question on this one on your test or homework, stuff like that, but I just understand that the purpose of finding the empirical probability is based on what you observe, you know, divided by the total of the trials. Okay, so when thinking about how to carry out simulation, look at several different methods to find an easier to carry out random action with the same probabilities. Okay, so for this one, you don't have to worry about it. So people using technologies to do it. Here are two examples, like just like the form, they just like kind of the same, okay, the same situation, but they're using different forms. So we call designing simulation. One of the example, let me see, here is the example. Here are two different valid methods that may be used to simulate a single flip of a coin. Okay. So based on this example, each digit will represent a flip of a coin. Okay, so we have odd digit, we have so in this case they throw you the odd value is 1 3 5 7 9, then they stop, so it's mean 5 times, right? 5 trials in this case now, and then the even digits represent the tails, which mean we have 2 4 6 8 and 10, right? Another 5, right? Because they stop at 9 right here for odd. So even will be 2, 4, 6, 8, and 10. So total for the number of tries in this case is 10. Okay. And so for example, in the question they might ask, so what is the empirical probability of getting a tail? Okay, then you will count, okay, the tail in this case represent for all the even digits. So will be 2, 4, 6, 8, 10, 5, right? So 5 over 10, you got 1/2, which is 50%. Part B, they want we to change different form of setting up the simulate, so that we can easier to count or look at the number easier. So they're using 0 and number 1. So 0 and number 1 usually they're using this in coding. 0 for like they could have different meanings. 0 for fail, 0 for false, 0 for in this case they want to use 0 for tails. Okay, kind of many examples like that. And 1 maybe some represent for true, some represent for success, and this case represent for heads, right? So many meanings. So if you're using 0 and 1 will represent for a flip of a coin, then the digit that they want you to use, 0 represent for tails and 1 represents for heads. And even though they don't given us like the number of trials, how many times that we flip the coin, but anyway, when we are whatever number of times that the question asking us, and if you write, you represent for 0 for tail, then every time that you flip a coin, you got tail, you write 0, and every time you get a head, you got 1. Something like that is up to you. So I'm using this two examples sometimes for students to do a project, like I want students to flip a coin like 50 times. So it's up to them that they will, sit down and, write it down, record it, whatever that they observe when every time they flip a coin. For empirical probability, every single of you might get different value because every one of you have your own experiment on flipping a coin 50 times. So you will have different value. So it doesn't matter. So for this empirical probability is just based on what you observe from the real experiment. Okay, that's the purpose. So the steps for simulation, so you identify a random action and probability of the successful outcome, determine how to simulate this random action using technology, random number table. So this two I'm not using a lot when you are doing the work, but when you're doing project, for example, I just give you like 20 or less. Oh, I'm sorry, 50 or less. So determine the event you are interested in. When we're talking about the event, it depends on the story, right? So sometimes we're talking about coins, sometimes we're talking about the buses arrive late, or sometimes you're talking about like how many cookies that you failed to do it or something like that. It's just like, it's up to the story. But usually for this case, we're using coins. Is easiest or simple for all students to understand. Explain how you will simulate one trial. Carry out a trial, record whether or not the event of interest occur. Okay. So depend on the story, they want you to find the tail or head. So that will become the interest event. Repeat the trials many times, at least 100 times. So see that the more number that they given us, the more number that you're doing it, you get close to the actual probability. So they recommend us to do at least 100 times. But like I said, I'm not going to give you that much, 50 or less. If this happen, if I choose this section for the project or something. If otherwise, you don't have to worry about this. And count the number of the times your event occur. Okay. Use the data to find the empirical probability. So at the end, the purpose is whatever that you record. Depend on the question they're asking, to find the empirical probability of the heads or to find the empirical probability of the tails. Then you record it. You record what you see, divided by the number of the number of trials. So here are the simulation for P of 3 heads when tossing a coin 3 times. So first, identify the random action and probability of a successful outcome. Random action is the outcome of a single coin toss. So here they give us, example is 50%. Determine how to simulate this random action. For example, using technology, random number table, use a random number table. So let even digits is tails and odd digits is heads. And 3, determine the event you're interested in. So for step 3, usually if I write a question, I will give you obvious what do you need to do. So right here, interested in whether we get 3 heads in 3 tosses. So explain how you will simulate one trials, read off 3 digits from a row table. So for all of this, like I told you, the purpose of all of this make you understand how to find the empirical probability of the interested events. That's it. Okay. So as you look at all the way to number 7, the formula to find the empirical probability is, okay, depend on the example that you record, you observe, and then the number. So empirical probability, that will be equal to the number of the yes. The number of yes in this case is the number of the success, or the number of that the question asked. divided by the total number of trials. So law of large numbers, but the purpose of this telling us that the bigger number that you do experiment on, the better results. The better the result will close to the actual value that they needed. Okay, it's not 100% accurate, but it's close to the actual value. So for large numbers, they're not using like under 100 times. They use 1,000 times, 10,000 times, and millions times. So for this case, usually they're using the technologies to do it. Okay, I think that's all. So again, the purpose of this is you don't have to worry much. You only need to understand that for every single experiment that you do, the actual, like value that you observe from your eyes, right? Observe and you recorded it, you remember it, then you will, divide it by the total of trials and you're done. So that is all for section 5.4. If you have any question, again, you can read more from the textbook or ask me. All right. So this looks like it's not a lot of like computation. It's just like how you're understanding it and apply a bit. And again, people not using this empirical probability in doing like kind of difficult math instead, but it's just like you when you do your real life, you're estimating it kind of quickly, then using this method. All right, class, see you next time.